first, I have an announcement. Tomorrow we are organizing the OCaml Hackers Meeting at our place here at Iril. It's 10 minutes from here. You are all welcome, but if you want to enter the building, you need an access card. So please write your name on this sheet of paper if you want to come to the Hackers Day tomorrow. Please. And we will give you the access card this afternoon. Okay. Maybe ask Grégoire for this. So my talk is about how to write a client-server web application in OCaml. But I promise that before doing this, I will unveil the new logo of the Ocsigen project. So, my first part is about the Ocsigen logo contest. And it's a good occasion to have a quick look on the history of the project. The project started in 2004. And we had the idea with Jean-Vincent Laudeau that the tools we were using, that were used to write websites, were not good enough. And they were designed at a time where websites were very basic, and dynamic websites were just about taking a set of data in a database and displaying them. And on client side, the situation was worse because JavaScript was not working well, it was very slow, and it was different from one browser to another. And there was Flash, but Flash had a great success because it was solving many deficiencies of JavaScript, but it is proprietary software and it is client-side only. And we had the idea that it should be possible to make web programming easier and more reliable by using a better language, and especially functional programming and static typing. We wanted to improve the reliability of websites. We wanted to make programming easier and shorter by using expressive features. And we wanted to have an unified way to program the three tiers, that is, all what's going on server side, on client side, and also the database interaction. There are several sub-projects. We wrote a web server, version 1 was released in 2008. Eliom is the framework for programming websites in OCaml. Version 1 was for server-side features, and now we are very close to version 2, which is for programming both server and client-side part of an application. We have the LWT cooperative thread library, JS of OCaml, and Macaque, which is a library for database queries using comprehension, and some other projects. This is the evolution of our logos. But for version 2, we needed a more professional image, and we decided to, as we are a collaborative free software project, we decided to make the community participate in creating the logo, and we created a collaborative logo design application. You can see it if I did an announcement last week on the Ocsigen list, and yesterday on the OCaml list. If you go to oxygen.org, the current version, you can try it now, but I'm not sure that the Wi-Fi connection is good enough for everybody. But thanks to this logo drawing application, we got very interesting proposal. Now it's time to unveil the winner. This is the third prize. Very nice drawing.
When did they get time to do that?
Yeah, I don't know.
3 AM or something?
Maybe. This is the second prize. And no, this is not the first prize. The logo we have chosen is this one. So now it's time to start my talk. But I think you are all jealous about our logos, and you all want such beautiful logos for your project. So instead of doing this talk, I will teach you how to write such logo drawing application. So my talk is about how to write a collaborative logo design application with Eliom. First, I will recall the basics of programming a website with Eliom. Eliom is a framework for programming the client and server part of a web application. The main notion is the notion of service. Service is a kind of function that will be called when you click on a link. It will be called by the server to generate a page. One of the main characteristics of our services is that they are first-class values. It means that you can manipulate service as any piece of data. For example, the function to create an hyperlink does not take the text of the URL as parameters, but the service. The consequence of this is that it's not possible to have broken links, as Eliom is computing the URL. And if you change the URL for one service, you won't have broken links because every link in the application will be updated automatically, dynamically, when creating the page. This is how we define a service. To define a service, we call the register service function. Basically, a website with Eliom is just a CMR or CMXS that is linked dynamically or statically with Ocsigen server. In this module, you can use that register service function. The first parameter is the URL. Here, the URL is my/service. Unit means that this service does not take any parameter. And then you have the function that generates the page from get and post parameter. Get parameters are the parameters in the URL, and post parameter are sent in the body of the HTTP request. There are several ways to generate pages. Actually, you can generate web pages or something else if you want, just by choosing the module in which you take the register service function. Here we are using HTML5.register function, which means that we are using the HTML5 module to generate HTML5 pages that are statically typed. That is, we are checking the validity of web pages at compile time. This is done by using this function. We have one function for each HTML tag. It is also possible to use a OCaml P4 extension to use usual HTML syntax. And here you have an example of a page with two links. The first one is a link to service S1. This is the text of the link, and service S1 is taking no parameter, and service S2 is taking two parameters, one integer and one string. I don't have time to speak about all the features of Eliom, but here is a summary of the main features. I think one of the most interesting feature of Eliom is service identification mechanism. That is a way Eliom choose the service that will generate the page. And what is interesting is that it is using very clear URL, as the user the programmer is choosing the URL he wants and the name of the parameters. That's not the case in every web programming framework. We have dynamic creation of services. That is continuation-based web programming. That is the ability to create dynamically new services with respect, for example, to data that were entered by some user. This is very easy to implement. Feature like a form that leads to another form and then another one, and the second form depends on the first one, for example. Depends on the data you put in the first form. For example, if you want to implement a website for booking train tickets, with this, it's straightforward. The usual way to do this is to create a table on the server, record the data in the table. It's not easy, but using dynamic creation of services, you can do this very easily. And we have a powerful session mechanism. I will speak about it at the end of the talk. Now, back to client-server programming. This is the full code of my logo drawing application. It is written very small. I don't want you to read it, but I want you to see that it is very small. It's only 75 lines of code. And I want you to see that it's only one piece of code for describing both what's happening on server side and on client side. And we have a syntax extension with this quotation here to separate between client-side code and server-side code. Here, the blue parts are server-side code, the yellow part are sent on the browser, and the green part are shared between the client and the server. The yellow parts are extracted at compile time by the OCaml syntax extension, and then compiled to JS using the JS OCaml compiler, and sent to the client. Okay. Let's have a look at the structure of this program. The first part does open, define some constants, and one type, the type messages. Then we are defining the information about the application, mainly the headers, the style sheets, and maybe some external JavaScript library you may need. The following client-side function, this one is the bus. Is the only one line to describe the bus. It's a communication means between the server and the client. The yellow part here is the draw function. That's the function I will use to draw a line on the page. Here I'm defining my service using register service. And the service is not returning a page, but this service is returning an application. This is, the yellow part is the code of the application that will be sent with the page. And here you have the content, the HTML content of the page, which is very simple. I have just one title, and that's all. In the yellow part here, I'm first defining my canvas, where I will draw the image. Then the slider. This is that slider to choose the size of the brush. Sorry. Then the color picker to choose the color of the brush. This is a set of function of value to compute the coordinates and send them to the server. Then we have one line here to tell the client-side program to react to server-side events, events. And then we have 4 lines to describe how we react to mouse events. Only four lines to do this. Well, just zoom on that part. This is the draw function to show that we are using the JS of OCaml compiler. You can recognize double sharp notation to call JavaScript function. We are using HTML5. The main part of the application is a canvas, which is a feature of HTML5. We are using also OClosure. OClosure is a binding we did for the Google Closure library. Google Closure is a library, widget libraries. It is the library that is used, for example, in Gmail, in Picasa, or in many Google websites. With JS of OCaml, it's very easy to write bindings for JavaScript libraries, and we have a full binding for this library. And here, the slider and the color picker is taken from that library. So the code is short, but not because we are using sophisticated function from a library. The only function we are using from libraries is the slider and the color picker. Now, the interesting part is how we communicate between the server and the client through this bus. I'm just defining on server side a bus with the function eliom_bus.create. As you can see, we are using a strange thing here, json.t messages. Messages is a type, and we are. This is a syntax taken from the deriving library. We are using the deriving library because, as the client is sending marshaled OCaml values to the server, we don't want the server to stop if the value is not correct. So we are using deriving to check that the value is correct before unmarshalling it on server side, so that the server can't crash. Actually, it's not exactly the deriving you can download on the deriving website. We have our own deriving version. We hope that we can converge and have only one deriving soon. On client side, when somebody writes something on the canvas, we just write eliom_bus. We use the eliom_bus.write function to write on the bus. This syntax with %, is how we can use server-side values in client-side code. This is available for many types. For example, here the bus, but also services or other values. And here, this is how we react to the event occurring on the bus. We are just telling that for each event occurring of the bus B, actually on the stream corresponding to bus B, we must call the draw function that is defined here. And obviously we have LWT on client side. Okay, this is the same. Here you have the server on 3 clients, the bus. Somebody is doing something on the first client. We are calling the write function, and then all the clients that are listening on bus B are receiving the event and drawing the family. Now, mouse events. Actually, with JS of OCaml, it's easy to use the usual JavaScript stuff for reacting to mouse events. You can write, add event listener, etc. This takes around 50 lines of code for this program. We want to explain that if you catch a down event on the canvas, then you must draw a dot and listen for move events or up events. It's quite complicated. But we have an experimental implementation of Eliom, which is much easier to use and much more concise, which is using arrows of functional programming. This is how we program the events in this application. Basically, this says for each mouse down events on the canvas, there is an S on mouse down because we want to iterate and to do this for each mouse down event on the canvas. Do the following. First, call the setCoord function. SetCoord is just a function that will record the current position of the mouse in some reference. Then behave as the first of these links to terminate. And in this list you have two lines. The second line is if you catch an up event anywhere on the document, then call the line function, draw a line. And the first line is saying if you have a move event, for each move event on the document, draw a line. Actually, the first line never terminates, and the first terminates when the second line terminates. And that's all. A few words about session. Sessions are used as usual for registering data, but it's also possible to register services in session on server side. And when you register some server-side data or service, you can choose if you want it to be, well, obviously you have an automatic management of session cookies, and you can choose the scope, the visibility of the services on server-side data. You can choose if your data is a scope for the whole site. For example, if you register a service by default with the register function, you have a service available for the whole site. But you can add the optional parameter scope to the register service function. And if you are at scope session, the service will be available only for the current browser session. But we have also other scopes. It is possible to register a service or data for one browser tab, that is for one client-side process. Actually, we are simulating cookies at the level of a process, a client-side process, at the level of a tab. Or the fourth scope is session group. You can group together all the sessions, for example, all the sessions for one user. This is a feature invented by Dario, which is really interesting because it's possible to close all the sessions for one user, for example. Now, obviously, all Eliom is available on client side. Actually, not all everyone, but all that has a sense on client side is available. You can use services on client side. You can use the same function to generate links or form on client side. And maybe one of the most exciting features of Eliom on client side is that a client-server web application is fully compatible with the old style web interaction. That means that if you click on a link or on a form on client side, the program does not stop. The client-side program does not stop, which is not the case when you have a page and you click on the link, you go to another page, the JavaScript program will stop by default. This is not the case with Eliom. We have implemented very sophisticated features to make the program continue on client side. This allows to, for example, to have state on client side for your application and to continue the client-side application, when you click a link, for example, if you want to implement something like Deezer or Music.me, when you can listen music, you can start your music. The client-side program is playing music, and you can continue clicking on links and navigating on your website to go to other music, but the music does not stop. And this is done automatically. You don't have to do anything to have this. This is the default behavior. This is something that exists in other websites, but it's very tricky to implement. With Eliom, you have this for free. Yes?
Do you support the storage extension for JavaScript in HTML5?
Do we support the storage for HTML5? Not for now, because we concentrated on features that are implemented in all browsers for now. That's the same for the Comet feature. Because I forgot to speak about that. When you implement a bus, for example, it's easy to speak to the server because you just need to create a service and the client-side program can call a service. But when the server-side program, the server wants to speak to a client-side program, it's more difficult to do because because it's not possible for a server to talk to a client with HTTP. There are several ways to solve this problem. Most of them are browser dependent. We implemented one that is compatible with almost all browsers, which is very basic. The client-side program is doing a request, and the server is responding only when it has something to say. But the good solution to do this would be HTML5 WebSockets, probably, when they will be implemented in all browsers, maybe one day. That's the end of my talk. You cannot. I wanted to do the announcement of Ocsigen 2.0 today, but it has not been possible. But you can download version 1.91, which is very close to version 2. The main thing that remains to be done is that it is not compatible with Internet Explorer. This is maybe some other small features that are missing. This is a list of contributors. The contributors that the authors that are written in big character are the ones who participated in the client-side version of Eliom. Okay, thank you. Any question? Yes.
Do you have support for localization?
Support for localization, what do you mean? On server side? Or?
Yeah, I mean, you want maybe your website to be available or your application in different languages, and is there some support to...
We have nothing for this, but you can implement easily this. I think there is
something about that.
Silver has something.
Yeah, you need to do some post-processing to extract certain languages preferences from the header. So once you know that, you can transfer it to getText, and using the pure OCaml implementation of getText, you can translate it. You can translate your web page using that. Yeah. But you have to put a lot of context, and I hope that using the LWT key storage, I will be able to create a version that will be really easy to use inside LWT thread. You will define the language context, and you will just have S underscore to translate the string just like in the text.
And you also translate the URLs?
No, you won't translate the URL. It's not part of it. Sorry.
Actually, I have a suggestion for naming convention. LWT is just not pronounceable. I suggest pronouncing it loot. Really?
Well,
Everyone stumbles on the word.
Jeremy, what do you think about this?
So, being new to web programming, I have a basic question, which is why does Ocsigen need this idea of lightweight threads when other web programming frameworks have no such constructs?
The question is, why do we need lightweight threads?
Right. I mean, I use Python Django, and there's no such thing, and my website runs fine. What? What's the problem?
Actually, a web server is a threaded application. There are several ways to implement thread. We could have chosen preemptive threading, but we think it's safer to use cooperative thread. The drawback of this is that we need to implement everything using LWT, and the user must be aware of this when writing the web page.
So, in other words, these other frameworks use the threading happens at the server level, so it's hidden from the web programmer. Because every click on a URL always starts a new thread?
No.
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 So
it would be possible to do this. Actually, with LWT, you can mix cooperative threads and preemptive threads. One way is to launch every handler function, every service in a preemptive thread, but you will need to do the usual stuff with preemptive threads, such as mutexes, etc. But you don't need this with LWT. But it's possible to do this. You can register, you can create your own register module to launch every service in a preemptive thread. It's possible to do it, but it's not the default. The default is to use LWT.
And also you tend to get better performance with cooperative threads, because with preemptive ones you always have to worry about the context switches. And most of the requests are actually very short requests. And having a pool of threads, for example, like Apache does, okay, you can do it, but it's quite heavy. And with loot, everything is very light. It's only odd at first because you really have to get used to writing your code cooperatively. But I mean, once you get past that initial stage, you get the impression that it's a much better way of doing things for the web. Also, you don't have to worry about mutexes and locks and all that kind of stuff.
I guess what I don't understand is I don't have to worry about that in Django either.
Yeah, because you guess each request probably runs in a separate thread, I guess, in Django, I'm guessing.
But do you have a state on server side? Because I think that's the same problem. If several threads are accessing the same data, you will have a problem.
Okay, so maybe that's...
Maybe the difference is here. That's with Eliom you program, you have a state, a server-side state in memory, and you must be aware of that.
Okay.
It's much like writing a usual program with, with OCaml.
But basically, if you want to program without LWT in Ocsigen, you just have to know that you just return the result, and that's all. I mean, and you can do everything, you can do the rest in not LWT way of doing things, and just do access to database, blocking access to database, there's no problem. You can do it. It's just not the best way to interact with Ocsigen, I think. Okay, thank you very much.